Testing. 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 All right, MATH0092. We're beginning with section 3.3 today. And we're going to look at subtraction of fractions. And our first example is 32 over 12, subtract 25 over 12. Now, with fractions, we have to remember that for addition, subtraction, we have to think about that piece of pie. The wedges have to be equal, so we're going to need a least common denominator. We have to be working with equal proportions. And I see that my denominators are the same. I have 12ths and 12ths. So equal denominators. So I can go ahead and rewrite this. My numerators all over a common denominator. Now 25 from 32 is 7, all over 12. 7 is prime, so I can't simplify that any further. Another example, 8/9, subtract 2/9. Well, I'm looking very carefully to inspect the denominator, and whenever I'm adding or subtracting fractions, I need to think about the piece of pie. This pie is cut into ninths, and this pie is cut into ninths, so I have a common denominator. So I can rewrite the numerators all over the common denominator. Simplifying numerators, 2 from 8 is 6/9. And we always want to simplify, so I want to look for another name for 1. I can factor then. That's 2 times 3 over 3 times 3. Factored, I see that I have 3 over 3, which is another name for 1. So I can simplify 6/9 to 2/3. Well, when we have different denominators, 2/5, and I'm going to subtract 3/8. This pie is cut into equal wedges of fifths, and this pie is cut into equal wedges of eighths, but they are not the same. And I remember when I'm adding or subtracting fractions, I have to think about the piece of pie. I need equal wedges, so I need a least common denominator. Well, I'm inspecting, I'm looking closely, and 5 and 8 are not the same denominator, so I'm going to build my least common denominator table, picking up all the denominators represented to calculate my least common denominator. Well, 5 is prime, so that's 1 times 5. 8 is 2 times 2 times 2. The first column, I always pick up all the factors, 5. In the second column, I don't have a factor of 2 yet, or another factor of 2, or another factor of 2. So 5 times 8, my least common denominator is 40. So now I'm going to convert 2/5 to its equivalency in 40ths. Let's see, 8 times 5 would be 40. I have 2 in the numerator. If I multiply the denominator by 8, I'm going to have to multiply the numerator by 8 as another name for 1. And we know that 1 times any number is the same value. Now in fractions, they may not look the same, but they have the same value. I'm going to subtract, and I want to change 3/8 to its equivalency in 40ths. So let's see, 8 times 5 would be 40, so I'm going to multiply the numerator by 5 as well as another name for 1. 1 times any number is the number itself. Now in fractions, they may look different, but they have the same value. So 2/5 in its equivalency in 40ths is 8 times 5 is 40, 8 times 2 is 16. We're going to subtract. 3 times 5 is 15, and 5 times 8 is 40. Now I can inspect and see that I have a common denominator, so I can write the numerators all over the common denominator, and 15 from 16 and 1/40th. My next example is 5/6, and I'm going to subtract 7/12. Now again, with adding or subtracting fractions, remember your cheat sheet, we have to have equal ratios in the pie. They have to be equal wedges. So I'm going to need a least common denominator. This pie is cut into 6 and this pie is cut into 12s. So I'm going to build my least common denominator table. Prime factor, this is 3 times 4, so 2 times 2 times 3. In my first column, I'm going to need both factors. None are represented yet. From the next column, I have a factor of 2, but I'm going to need another factor of 2. I have a factor of 3, so I can check it off. So 4 times 3 is 12. So our common denominator is 12. So I'm going to build 5/6 to its equivalency in 12s. Well, 2 times 6 would be 12. So I'll multiply the numerator by 2 as another name for 1. And 12ths is already in 12s, so I'll just carry that down. 2 times 5 is 10. 2 times 6 is 12 minus 7/12. Now I can see that I have my common denominator, so I can write the numerators all over the common denominator. And 7 from 10 is 3/12. And simplifying, 3 goes into 3 and 3 goes into 12 evenly. So I have 3 goes into 3 once and 3 goes into 12 4 times. Now our next topic is order. We want to know if one value is larger or smaller than another value. So we're going to compare 2/5 to 3/4. Well, again, we can't compare unless we have a least common denominator. And 4 times 5 is 20, so we're going to use 20. 5 goes into 20 and 4 goes into 20. So I'm going to convert 2/5 to its equivalency in 20ths. So 4 times 5 is 20, so I'll multiply the numerator by 4 as another name for 1. We're comparing. And I'm going to convert 3/4 to 20ths. 5 times 4 is 20, so I'll multiply the numerator by 5 as another name for 1. That's 8 over 20 compares to 15 over 20. And now comparing numerators, 8 is less than 15, so 8/20ths is less than 15/20ths. We need a common denominator in order to compare. We're looking at order. I have 9/10 compares to 89/100ths. Well, tenths and 100ths are not equivalent, so I need to determine my least common denominator. 10 is 1 times 10, and this is 10 times 10. I need a factor of 10 from the first column. From the second column, I already have a factor of 10, but I'm going to need another factor of 10. So my least common denominator is 100. 10 goes into 100 evenly, and 100 goes into itself evenly. Well, I'm going to convert tenths to its equivalency in 100ths. 10 times 10 would be 100, so I'm going to multiply the numerator by 10 as another name for 1. We're comparing. I'm going to convert 89/100ths to its equivalency in 100ths, and it's just already in 100ths. so I don't have to do any converting. 9 times 10 is 90 over 100, compares to 89 over 100. I have common denominators, so I simply compare the numerators. 90 is actually greater than 89. Next, we're looking at equations. Now, my goal is to be able to say that x equals. I'm trying to solve for x, and your directions will typically just say solve. Solve for the variable. You might be solving for t or s or r. In this case, our variable is x. Now, I know that if I add the opposite of 1/4, and I subtract 1/4, I'll have x equals. That's my goal, getting there. So I added the opposite. But if I add the opposite to this side of the equation, I need to add the opposite to this side of the equation. Now my goal, this is x plus 0. A positive and a negative goes to 0. X plus 0 is x equals. So I have a start with my goal. But what's left on this side, I have 3/5 minus 1/4. So to solve for x, I'm subtracting. I need a common denominator. Adding, subtracting, fractions, I think of the pi, I need a common denominator, and that's going to be 20. 5 goes into 20, 4 goes into 20. So I'm going to convert to their equivalency in 20ths. 3/5 converted to 20th, that'd be 4 times 5, so I'll multiply the numerator by 4 as another name for 1. And 1/4 converted to 20th would be 5 times 4, I'll multiply the numerator, 5 over 5. 4 times 3 is 12. 4 times 5 is 20. 5 times 1 is 5. 4 times 5 is 20. I see now that I have common denominators, so I can write the numerators all over my common denominator. 12 subtract 5 is 7. 20th. 7's prime. Adding or subtracting fractions, we need to have a least common denominator. This is on page 175. Miguel jogs for 4/5 mile, rests, and then jogs for another 2/3 mile. How far does he jog in all? So we're looking at a total. I think I'm ahead of myself here a little bit. Looking at page 166. There we go. And we're going to be adding and subtracting fractions. For a research paper, Caitlin spent 3/4 hours searching the internet on google.com and 1/3 hour on chacha.com. How many more hours did she spend on google.com than chacha.com? How many of you have used chacha.com? Might want to check that out. So Caitlin spent 3/4 hours on Google and 1/3 hour on Cha-Cha. How much more time did she spend on Google? We're going to compare. We want to find how much more than, so 3/4 is how much more than 1/3? Well, we're adding and subtracting fractions again. So we need to check the piece of pie for a least common denominator, and they are not common, but 4 times 3 is 12, so we can convert to 12s. 3/4 converted to 12, that's 3 times 4 is 12, so I'll multiply the numerator by 3 as another name for 1, and convert 1/3 to 12s. 4 times 3 is 12, so I'll multiply the numerator by 4 as another name for 1. 3 times 3 is 9, 3 times 4 is 12, minus 4 times 1 is 4, 3 times 4 is 12. Now I do see that I have a common denominator, so I can write the numerators all over the common denominator, and 4 from 9 is 5 12s. Now remember that this is a story problem, so we do want to make sure that we label correctly. In your homework, just practice and make yourself label our story problems and application problems. At my math lab, they'll have most of the labeling accomplished for us. Every once in a while, you'll have to put in a unit measurement. So 5/12 hour more was spent on Google than Cha-Cha. Okay, on page 166. Number 59. The tread depth of an IndyCar Series tire is 3/32 of an inch. Tires for a normal car have a tread depth of 5/16 inch when new and are considered bald at 1/16 inch. How much deeper is the tread depth of an IndyCar tire than that of a bald tire of a normal car? We have to be careful here now. We're looking for the IndyCar tread and a bald tire tread. So the Indy tire tread is 3/32. And the tread of a new tire is 5/16 on a normal car, but is considered bald at 1/16 of an inch. So 1/16 of an inch. So there's some extra information shared with you in that story problem, having you decipher and logically research that problem so we can come up with our math model. So we're finding the difference. So we'll be subtracting. 32 subtract 1/16. And again, we need a least common denominator. And let's see, 16 times 2 is 32. So 32 is going to be our common denominator. Just going to carry this forward then, 3/32, subtract. We're going to convert 1/16 to 30 seconds. So that'd be 2 times 32, or 2 times 16 is 32. Multiply the numerator by 2 as well. So our other name for 1, we're not changing the value of these fractions, we're just changing how they appear. 2 times 1 is 2, and 2 times 16 is 32. Now I see that I have my common denominator, so I can write my numerators all over the common denominator, and 2 from 3 is 1. So I have 1/32, and we're looking for how much deeper is a tread depth of an Indy car than that of a bald tire of a normal car. And so this is in inches. Remember, with story problems and applications, we're trying to state the unit measurement and make sure that we complete in sentence form our final answer if necessary. Number 60. Jerry uses 1/3 pound of fresh mozzarella cheese and 1/4 pound of grated Parmesan cheese on a homemade pizza. How much more mozzarella cheese did he use than Parmesan? So Jerry used 1/3 pound of mozzarella cheese. And we want to know how much more mozzarella cheese he used than Parmesan, and he used 1/4 pound of Parmesan. Now we're finding the difference again. How much more? So 1/3 minus 1/4. We need that common denominator, and 12 will be our common denominator. 1/3 converted to 12s. 4 times 3 is 12, so I'll multiply the numerator by 4. And converting 1/4 to 12s, 3 times 4 is 12, so I'll multiply my numerator by 3 as another name for 1. 1 times any number is the number itself. The value remains the same. With fractions, it appears differently, but we're converting equivalency from thirds to 12s and fourths to 12s. So 4 times 1 is 4, 4 times 3 is 12, 3 times 1 is 3, and 3 times 4 is 12. Now I see that I have my common denominator, so I can write my numerators all over the common denominator. 3 from 4 is 1/12. So how much more mozzarella cheese does he use than Parmesan cheese? 1/12 pound. Well, then we start looking at some terminology regarding fractional use. When we talk about a proper fraction, the numerator is less than the denominator. Now, this makes sense because a proper fraction itself means part or portion. Of the whole. And of the whole, we're talking about the word HOWLE. So it's a fraction. A proper fraction is a part of the whole. So a part could be 1/4 or 2/4 or 3/4, but 4/4 would be the whole pie itself. So examples are 3/4. The numerator is less than the denominator. 7/8. The numerator is less than the denominator. 1/2. The numerator is less than the denominator. Now an improper fraction. Well, this key word im means not. So improper is not proper. And our example then is the numerator is greater than the denominator. In examples here, we have 8/3. The numerator is much more than the denominator. 7/4. The numerator is greater than the denominator. And 11/5. The numerator is greater than the denominator. Another form of representing fractions is mixed numerals. Mixed numerals, we're going to have a whole number part with a fractional part. Now examples of that might be 2 and 3/8. 2 is a whole number, and 3/8 is a proper fraction. 7 and 2/5. We have 7 as a whole number and a fractional part of 2/5. 4 and 3/10. We have 4 whole pies and 1 pie cut into tenths with only 3 parts represented. So now we want to be able to convert between these number formats. So to convert to a mixed numeral, if I have 7 plus 2/5, I can represent that as a mixed numeral. That is a whole number with a fractional part. Right now we have a whole number added to a fractional part. So I have 7 and 2/5 as a mixed numeral. I'm supposed to add 4 plus 3/10 and show my answer as a mixed numeral. That is with a whole number part and a fractional part. So that would be the mixed numeral 4 and 3/10. Now we're asked to convert to a fraction notation. Notation is just another word for format. And fractions have a numerator and a denominator. So 2 and 3/4. This is in mixed numeral format now. And we want to convert it to its equivalency in fractional notation. So I know I have 2 plus 3/4. 2 is a whole number. I can write that as 2 over 1 plus 3/4. And I remember then that to add, I need a common denominator. So I want to make 2 into fourths. 2 over 1, I'm going to multiply by 4 in the denominator to get my common denominator. I'll have to multiply by 4 in the numerator. Plus, and 3/4 is already in fourths. 4 times 2 is 8. 4 times 1 is 4, plus 3 over 4. Now I have common denominators, so I can add my fractions all over the common denominator of 4. And 8 plus 3 is 11/4. Now, this is in fractional notation. There is a numerator, there is a denominator. They didn't ask for proper or improper. Four and 3/10. Okay, this is a mixed numeral. And we're supposed to convert to fractional format. Fractional format notation means we have a numerator and a denominator. So 4 is a whole number plus its fractional part. I need to have a common denominator, looks like 10. So I'm going to convert 4 over 1 into tenths. 10 times 1 would be 10, so I'll need to multiply the numerator by 10 as another name for 1, plus 3/10 is already in tenths. 10 times 4 is 40. 10 times 1 is 10 plus 3/10. I have a common denominator, so I can add my numerators, plus 3, all over the common denominator, and I get 43/10. Another example, 6 2/3. That's mixed numeral. And we're supposed to convert it to its equivalency in fractional form. So I have 6/1 as a whole number plus 2/3. I'll need a common denominator. So I'm going to convert 6/1 to thirds. That's 3 times 1 would be 3. So I'll multiply the numerator by 3. As another name for 1, 2/3 is already in thirds. Just carry it forward. 3 times 6 is 18. 3 times 1 is 3, plus 2/3. I see I have a common denominator, so I can add the numerators all over the common denominator, and I'll get 20/3. Now we're asked to convert a fraction to its equivalent mixed numeral. So I have a fraction, 69/10. The numerator is greater than the denominator, so I know that I can represent this with a whole number and a fractional part. So actually I have 10 goes into 69 how many times? Well, with my calculator, (69) divided by 10 is 6 point. So that's 6 plus a little bit. 6 is my whole number. So it goes 6 times plus a little bit. So I'm going to just go over here and take 10 times 6. 10 times 6 would be 60. Not quite enough for my dividend, but I can subtract 60 and get the whole number 9 as a remainder. So your calculator is going to show your answer when you divide in decimal format, and we're going to have to convert that back so that we can show our answer in the equivalent mixed numeral format. So I have 69/10 is equal to 6, we know that, plus a little bit, which is 9/10. The remainder over the divisor. So 69/10 is in mixed numeral format equal to 6 9/10. 122/8. Well, we want to use our calculators to help us here. This is division, so 122 is divided by 8. 122 divided by 8, we get our whole number portion, which is 15, plus a little bit, a decimal portion. So we're going to pick up 15 from our calculator. And then 8 times 15 should be close to our dividend. 8 times 15 is 120. So I'm going to subtract that. And now I have 2. So I have a remainder of 2. So 122/8 is equal to 15 and 2/8. And because both are even, we're going to simplify further. 15 and 2 goes into 2 once, 2 goes into 8 4 times. So I have 15 and 1/4. Now you may need to practice a little bit with your calculator. Remember, Google Calc is a good calculator free resource that can help you with these problems. but we're using our calculator to find the whole number portion when we divide, and then longhand determining our integer remainder. And then be sure to simplify. So now on page 175, we'll look at a couple of our story problems. Miguel jogs 4/5 mile, rests, and then jogs for another 2/3 mile. How far does he jog in total? So we're going to want to add 4/5 mile plus 2/3 mile. Well, we need to have a common denominator. Adding, subtracting, fractions. Think about your piece of pie. This one's cut into fifths. This one's cut into thirds. They are not equal, so we need a common denominator. Well, 3 times 5 is 15. So we'll convert to 15ths. 4/5. 3 times 5 would be 15. I'll multiply the numerator by 3 as another name for 1 and 2/3, converting to 15ths. 3 times 5 would be 15, so I'll multiply the numerator by 5 as another name for 1. 3 times 4 is 12, and 3 times 5 is 15. 5 times 2 is 10, and 5 times 3 is 15. So now, with my eagle eyes, I see that I do have a common denominator, so I can add my numerators all over a common denominator of 15. 12 plus 10 is 22/15. So he jogs 22/15 miles in total. Our next problem on page 175 is number 17. One weekend, Kirby spent 39/5 hours playing 2 iPod games, Brain Challenge and Cerebral Burn, and Scrabble. Go to a triple word score. She spent 11/4 hours playing Scrabble. How many hours did she spend playing Brain Challenge? We have to compare 39/5 hours, subtract 11/4 for Scrabble. So comparing the difference, we have 39/5 subtract her Scrabble hours of 11/4. And again, we need a least common denominator, which will be 20. 5 times 4. So we're going to convert 39/5 to 20ths. So 5 times 4 will be 20. I'll multiply the numerator by 4 as another name for 1, and 11/4 converted to 20ths. 5 times 4 is 20. I'll have to multiply the numerator by 5. 4 times 39 on my calculator is 156, and 4 times 5 is 20. Subtract 5 times 11 would be 55. 5 times 4 is 20. Now I see that I do have a common denominator, so I can subtract my numerators all over the common denominator of 20. And 55 subtracted from 156 is 101 over 20. Found the difference. Number 18, arrange in order from smallest to largest. I have 4/9, 3/10, 2/7, and 1/5. Arrange in order from smallest to largest. 4/9, 3/10, 2/7, and 1/5. Now we want to do this by comparing the order. So which is the smallest of these fractions? And in order to determine order, we're going to have to find a common denominator. So my common denominator, I have 9, 10, 7, 5. I'm going to build my least common denominator. Prime factorization, 9 is 3 times 3, 10 is 2 times 5, 7 is prime, 1 times 7, and 5 is prime, 1 times 5. From the first column, I need all of the factors because there are none represented yet. From the second column, I need a 2, not represented. I need a 5, not yet represented. From the third column, I need a factor of 7, not yet represented. But from the last column, I already have one factor of 5 represented. So I have 9 times 10 times 7. 90 times 7 is 630. So my common denominator is 630. So now I want to convert each one of these to their equivalency in 630ths. So I'm going to convert 4 9ths to 630ths. Now 9 times 70. So I'm going to multiply by 70. 70 times 9 would be 630, so I'll have to multiply the numerator by the same as another name for 1. 3/10 converting to 630. 10 times 63. So I'll multiply the numerator by 63 as another name for 1. 7. Convert 2/7 to 630ths. 7 times 90. 90 times 7 would be 630 as another name for 1. And 1/5, I'm going to convert to 630ths. 1/5, that'd be 5. So I have 9 times 14. 9 times 14 is 126. So 126 over 126. And I'm going to double check. 126 times 5 equals 630. So sure enough, that was my 126 times 5 is 630. All right, so now I'm able to convert to 630ths. 70 times 9 is 630. 70 times 4 is 280. 63 times 10 is 630. And 63 times 3 is 189. Ninety times 7 is 630. 90 times 2 is 180. And 126 times 5 is 630. We made sure of that. And 126 times 1 is 126. Now I see with my eagle eyes that I have all common denominators. So I'm just going to compare the numerators. So the smallest numerator is right here. That's the first. The second is 180. The third is 189, and then the largest is 280. So now my smallest fraction of this group was 1/5. So I'm writing from smallest to largest. Next is 180 over 63, which is 2/7. Next is 189 over 630, which is 3/10. And the largest is 4/9. So in order from smallest to largest, I have 1/5, 2/7, 3/10, 4/9. So again, order, you need to have a common denominator, and then you can compare the numerators to arrange to a specific order. Number 19, looking at our mid-chapter review on page 175, we're supposed to solve 2/5 plus x equals 9/16. 2/5 plus x equals 9/16. And remember, our directions simply say solve. So our goal is, we want to be able to say the variable, in this case x, equals. We're solving for the solution for x that's going to make this equation true. So x equals means that I need to isolate the variable, get the variable on one side of the equation all by itself. And so if I add the opposite of 2/5 to both sides, adding opposites goes to 0, so I get 0 plus x is x equals. That's pretty close to my goal, but I'm going to have to tidy up this side of the equation. I have 9/16, and I'm going to subtract 2/5. What I do to one side of the equation, subtracting 2/5, I have to do to the other side of the equation, subtract 2/5, to maintain the pendulum, to keep things balanced. Well, now I'm subtracting fractions, so adding or subtracting fractions, we need to think about the piece of pie and the least common denominator. They are not common, so I'm going to have to build or find my least common denominator. Well, 5 is prime times 4 times 4. I'll need 4 times 4. From the first column, I'll need a factor of 5. 16 times 5 is 80. As my least common denominator. So I'm going to convert 9/16 to 80ths, and 16 times 5 is 80. So I'll multiply the numerator by 5 as another name for 1. And I want to convert fifths to 80ths. So 2/5. 5 times 16 would be 80, so I'll multiply the numerator by 16 as another name for 1. X equals 5 times 9 is 45, and 5 times 16 is 80. Subtract 16 times 2 is 32, and 16 times 5 is 80. Now with my eagle eyes, I see that I have my common denominator, so I can subtract my numerators all over the common denominator of 80. 32 from 45 is 13 over 80, and 13 is prime, so I can circle my answer. Number 21, which of the following is a fraction notation for 9 3/8? Well, we want to convert to a numerator and a denominator equivalency for 9 3/8, which is in mixed numeral format. It's in mixed numeral. And we want to convert to its equivalency in fraction format, which is a numerator and a denominator. So I have a whole number 9 over 1 plus 3/8. I'm going to need a common denominator, which is going to be 8. So I'll convert 9 to its equivalency in eighths. Multiply the denominator and the numerator by 8 plus, and this is already an eighth, so we'll just bring that down. 8 times 9 is 72, and 8 times 8 is 8, or 8 times 1 is 8, plus 3/8. Now I see that I have my common denominator, so I can add my numerators all over the common denominator of 8. So 9 and 3/8 in mixed numeral format is equal to 75/8 in fractional format. Now this, at my math lab, is an example of a multiple choice question. And we have 75/8 as our answer. So we're going to want to indicate, in this case, it'd be option C, 75/8. The next, which of the following is mixed numeral notation for 39/4? So we have 39/4, and that's fractional notation. And we want to find its equivalency in mixed numeral notation. Mixed numeral means we have a whole number and a fractional part. So this is 39 divided by 4. We're going to use our calculator to help us, and you can use Google Calc as well. 39 divided by 4 goes 9 plus a little bit. So 9 times 4 is 36. Subtract to find the difference, and we get 3. So we have a remainder of 3. So 39/4 is equal to the whole number 9 plus 3/4. Mixed numeral 9 3/4 is equivalent to a fraction of 39/4. All right, please return to D2L Brightspace for all details regarding homework, assignments, tests, and their due dates. And thank you very much.